Hello, my name is Julien. I'm a staff backend engineer at Qonto, and I've been at Qonto for about less than 4 years now, and this is where I discovered the Qonto Ruby standard. So today I would like to take you on a bit of a journey together to explain to you a bit how things started at Qonto, tell you about the problems that we faced that led us to build this Ruby standard. After I will give you some, let's say, some big guidelines, sorry, big guidelines of how the standard was built around, plus some examples of how it looks. And after we'll take a bit of time to reflect on how we released this standard and how it was received in the company and what we currently offer to our internal engineers so that they can understand this standard and use it on a daily basis. And at the end, we'll have a Q&A session, so if you have any questions, feel free to ask at the end. All right, so let's go down a bit memory lane. So at the beginning at Qonto, there was only one team, right? It was a small team of engineers, and one of the applications that they built was a Ruby on Rails monolith, which is called Qonto API. This application handled a lot of different things, creating bank accounts, making transfers, etc., etc. So he had quite a lot of responsibilities. At some point, as Qonto grew very, very fast, we had to basically create teams, right? Because you have to allocate part of the applications to specific teams, and you have to make them work together, right? As most of you probably know, the Ruby on Rails is let's say, architectured around the model view controller pattern. So at the beginning, if things are quite small, it's quite easy to add features. You have models that grow, you have controllers that grow, but things are okay, right? But after each feature that you add, you have more and more business logic, and you don't have, like, let's say, a natural place to put your code. So things started to get a bit less maintainable for us. So what we did was mostly introduce a service layer. So we introduced service objects. It's kind of the classical thing that we did. And basically that was, let's say, good enough at the beginning because it allowed us to extract all the business logic that was living in our models and our controllers. And we ended up putting it into services. So that was okay because you have nicer responsibilities. You have your services for the business logic, and you have after models and you have controllers for the other part of the application, but at least everything is easier to test, easier to maintain, etc. Well, actually, we're not very happy about this at some point because as Qonto grew very, very fast, we needed to create more and more features to handle more and more use cases. And the thing is that at some point we reached about 200 services. So that was more than all of our models and controllers combined. So things started to impact our delivery and how we release features. And so we ended up in a situation like this. So I don't know if there's Italian speakers here, but it's what we call the spaghetti code. It's basically you have services calling services calling services. So you end up in a situation where everything is entangled. Every team is working on the same file, so you have ownership issues because everybody wants to interact with everybody. You don't have very good boundaries in this kind of architecture, let's say. And you have basically ownership issue because teams don't work as best as they can together. So that created us a big, let's say, bloat in terms of a release. And it also impacted the quality of our developments. And to give you an example on when we realized that something started to go wrong, is that Qonto API monolith handles, like I said, a lot of things. And it also handled something which is called attachments. So you can imagine attachment as being kind of file that are connected to different entities, such as a transaction, a transfer, mandates, whatever. So basically, once we added features on attachment, the thing is, like, at some point, we need to touch a lot of different parts of the application, right? We touched transfers, transactions, mandates, whatever. So that meant that we needed to have a very good, a big impact, let's say, on the code base. And at some point, nobody was quite comfortable in deploying code because since everything was coupled and entangled, we were quite not very, let's say, not very confident in the code, and we could only rely on our test to make sure that we don't break anything. But it clearly showed us that we had some issues. And the thing is that at Qonto, we really value scale and quality. And basically, we knew that we needed to do something because as we kept growing, the organization of the let's say of the company caused us a lot of issues. So to recap, ownership, because nobody was really knowing what they own, etc. We had coupling between teams because everybody interacted in a different way together. And you have also a code base that started to be a bit painful to maintain because at some point everybody has also its own style of writing things. So it made things quite complicated to work, and it impacted again let's say the quality of our work and the pace of delivery of Qonto. So this is what led us to think about how we could build a standardized approach in our code base. So, sorry. One thing that we could notice is that at some point we wanted to scale this big application, and when we looked at what we could do, two things stood out. One thing was service objects, which we're already using but was not enough for our use cases, and the other thing was microservices. And if we want to go with the first option, for sure it's not enough, like I said. And the second option around microservices, the issue is that it's a very costly option. It's a very long option as well to take because it's a very big application, and we could not wait for months or years to extract part of the application because we had problems at the time that needed to be addressed very fast, and we could not wait that much. So we ended up in doing a compromise in having kind of a microservices architecture inside a monolith. And this is what led us to build our standard and to define, let's say, rules and guidelines to make sure that we fix our organization issue and delivery issues. So if you want to split up a very big code base, you have a lot of different ways that you can find to do this. We can talk about engines, we can talk about components, namespace, however you want to call them. On our side at Qonto, we value a lot the domain-driven design approach, and we talk a lot of, let's say, we want to bring our code base closer to all these patterns. And what we chose as to fixing our ownership issue and building our expertise per domain is to use bounded context. So you can imagine a context as being its own little world where you can basically set your own rules. You can have your own language, which is basically driven by the domain that you're interacted in. And the good thing with this is, like, if you put different contexts and you assign them to teams, basically each team will build kind of an expertise on this domain, right? So what's the good thing about this is, like, if you manage to have your very big code base, all right, everything is shutting down, no worries. But yeah, anyway, it's like if you manage to have your very big application split into specific contexts, you're able to build your expertise between the teams. You're able to make sure that teams can communicate well together. And basically on this diagram that you see on the screen, you can imagine the context as being the gray boxes. So there are basically let's say, the boundaries for each part of your application that makes sense in terms of domain. And after, inside each context, one of the rules of the standard that we put in place was that you can only interact with the context by using the context services. So every context exposes specific services that allows you to know what are the different entry points that are available. And so once you have this layer of service, after, everything that is inside is kind of private. So after it's up to each team to decide what they want to do. Our standard usually guides you towards using 2 layers, let's say, to implement in your service. First is the contract part, where basically you can validate the input that comes in, so that you can react to the person calling the service. And the other part is the commands. So basically, you can imagine commands as being a specific interface that allows you to encapsulate a business step. So the good thing about encapsulating every business step in your context allows you to share these common steps between your context. So you have multiple services basically calling potentially the same commands, and you can reuse this code. The good thing also we like with this kind of vision is that you see that the flow is going in the one direction, right? So it's always from service to command. Code is very the design, let's say, is very explicit and very you can clearly see the purpose of the architecture. I will give you, of course, some examples later on so that it's a bit more explicit for you, because maybe I'm talking a lot of theories. But the good thing is, like, since we have this one direction flow, you don't have spaghetti code anymore, because since services cannot call each other directly, this way you can see that it only goes into this direction. Just a side note in terms of how it's structured into our Rails application. So with this introducing of context and services, etc., we introduced a context folder inside the app directory. So this is where you can, let's say, encapsulate the different context of the application. The good thing is, like, this way you have a very big monolith, but since everything is kind of organized into context, you can also easily navigate into the different contexts of the application to understand what are the different contexts available, or create new ones if you feel like your business logic requires it. Here I give you some, let's say, some examples of how we name things. The idea was mostly for context services to be a reflection of the action that you want to perform or to do. So that gives you, for example, transaction search service. We do the same for commands to have kind of this procedural approach to make it very easy to reason about. And for the contracts part, so the validation layer, basically we use the same name of the contract as the same name of the service. This way you're able to make sure that this contract fits this service basically. And I hope I was quite clear on the theory part, and now I want to give you a bit of code examples. And I will also try to be quite precise and explicit about it, but bear in mind for now the bind method that you see on the screen. For now, I just want you to look at this service, which is called the transaction search service, just to see that it's, let's say, the flow and how it's implemented is quite simple, right? The first thing is, like, it validates the contract, so you're calling a contract interface. Then after, you execute multiple commands, and at the end, you're returning success. I will just show you not to spend too much time on the syntax, because I will give you a bit of context in a few seconds or minutes, depending on how I speak. But if we look at how commands looks like, we also see that here it does something, and basically after it returns success or failure. So it's something that we try to implement in all of our different interfaces to have everything returning success or failure. And I will talk about why we implemented this kind of pattern after this slide. But bear in mind that for contracts part as well, we have a specific syntax, but at the end of the day, what it does is mostly returning success or failure if something goes right or wrong. And one thing I would like to mention about why we implemented success and failure on all those different interfaces, it's because we took a lot of inspiration from railway-oriented programming, which personally would kind of change how I code and how I think about structuring my code and how I develop my let's say, my business flow. The idea is that usually when we build something, we always think about the happy path, and we never think about the unhappy path. So if things goes wrong, basically we don't have any good solutions or good ways to handle them. The nice thing about this railway-oriented programming mindset is that it forces you to build something to handle the success and the failures as well. So that's why we try to we expose basically either success or failure to everything that is called in our let's say public interfaces. So the let's say the tooling to reach this is to use what we call the result monad that is coming from the dry monads gem. So for those who know, this is a gem that is available from the Paris.rb suite, which provides a lot of different tools, let's say, for a Ruby application. One of just a quick aparté for I don't know how to say aparté in English, so I say it in French. But one side note, sorry, on the monads, because it's come from functional programming, and for me personally, it was quite complicated to understand exactly and to have a clear definition. But my own definition of a monad is mostly that a monad is a wrapper around a chain of operations, and basically, if you have multiple steps to execute, if one of the steps fails, you just don't execute the next steps and you just stop there, right? So a result monad, you have different types of monad. You have list monad, maybe monad, result monad, whatever. Here we are interested in having this success or failure flow. So for this, it's what we call the result monad. If you call a result monad, it always gives you success or failure. So it's what we have in our examples right here, for example. And basically, we have built our own Qonto monadic gem, which is a private gem that is a wrapper around dry monads, and basically gives us success or failure for every interface that we have. We also added a bit of syntactic sugar, let's say, to have this bind method here. So it allows you to say, okay, if the first part, if the contract is not, it returns a failure, we'll just stop here and don't execute the rest. If it returns success, we go on the next line, etc., etc. That really allows us to go into one direction, again, like we said, and to return specific failures depending on what step of the business flow failed. And the last part I want to show you, because hopefully this will be a bit more, let's say, concrete or explicit to you, is that since we have everything mapped as success or failure, once we call the public interface of a context, so from the controller you can call your service, we can use Ruby's pattern matching to act upon the response of the service. So if we have a success here, we see that we return a 200 with a list of transactions. But if we have a contract failure, for example, we return a 422. And if we have another error that is related to something that failed in the business step, we return 500 or whatever. So this really allows us to be explicit on how we deal with failures at Qonto, and this really helps us also handle retries, timeouts, whatever, because we're always able to map failures to a specific business flow. And this leaves exceptions, Ruby exceptions, as unhandled cases, and that's really something that allows us to make sure that we have a, let's say, clean code base and easy to reason code base. I have 1 minute in front of me, so this will be good. This is the last part of the talk, mostly about talking about how we released this standard and what are the difficulties that we faced. So one of the major part that was a bit challenging and that's still challenging is to define a context, because domain-driven design is very, let's say, subjective, and you can of course have a lot of you can ask 10 people what is the domain, what is it. People will always have a different answer, but I feel like at some point the best solution is to define something that makes sense to specific teams, to capture the right abstractions, to capture the right data, and to make sure that you define stuff that makes sense to you, right? So that's what we do, and we also iterate a lot with experience to make sure that we build context and domains that make sense. One of the other challenge was onboarding people because this Qonto Ruby standard started very small and applied very locally, and after we needed to apply it to the different teams at Qonto. So it's something that we gradually did, as well as put some, let's say, some kind of some documentation for people to be able to have a look at and to be able to contribute also if they want to. And the last part is that we have internally also built a Ruby Academy. So it's basically a kind of a self-service academy where you can watch courses made by the different engineers at Qonto around the standards and around Ruby as well, because we have also different languages at Qonto, and let's say people also want to learn Ruby, but they also want to learn why we implemented the standard and how it works. So that's kind of the kind of the support that we also provide internally for that part. And that's it. So thank you very much. And if you have questions, don't hesitate.